gear panel talk today. I have some very fabulous workers manufacturers of equipment here with me today. So what I suggest is I will start off asking them to introduce themselves very quickly, and then we'll go over to the questions. If you guys have any questions, you know there's a microphone floating around, so don't hesitate, since I want to keep it an open discussion. So if you want to, you don't have to wait until the end for questions. We can kind of play on that as well. But maybe let's start off with the introductions. Maybe we'll start here.
Yeah, I'm Jesper Bo. Not really a manufacturer. I work for a good friend of mine who's a manufacturer, John Peterson, who does tube tech equipment. But my relationship to that is that I'm a recording engineer and I've been a friend of his, and my whole career I've been working with his stuff and of course other equipment also, but I've spent like 30 years working with tube equipment. So that's my life.
Hi, I'm Ivana Manley, and I own Manley Labs, and we also build tube equipment in California, and I've been doing that since 1989. That's what I do.
My name's Dave Collins. I'm a mastering engineer. I'm not a gear manufacturer at all. I might be at the wrong panel, actually.
I think you're on the right one.
But I have used a lot of analog and digital gear over the last 30 years, and hopefully we'll have some answers to questions. We'll see. But I have done some design work for my wife, Ivana, recently on some new products, but primarily a sound engineer.
Oh, I guess that's me. Yeah, I'm Dave Hill and I'm spacey today. But Cranesong, Dave Hill Designs, of course I'm a manufacturer but also recording engineer. And I do tube and I do analog and I do DSP. I kind of bridge all of the above worlds. And sometimes it's good and sometimes you lose your hair.
Yeah, I can subscribe to that. My name is Leif Masters. I've got a company called Masolek. I do also equipment that is sold by Prism Sound. I started as a recording engineer and producer, and gradually I stopped, and I'm now focusing on manufacturing and designing audio gear.
Okay, well, thank you everybody. I want to start off with the first question, which is mostly related to the design process. So I want to kind of hear from you guys, like if you have a new equipment in mind, like what are the first steps you go about? Do you have from the beginning a clear set of this is what I wanted to do, or does it kind of builds up as you go along?
Well, there's really, this is sort of a trick question in a way, because there's multiple approaches you can take for designing stuff. And you can sit down and define everything ahead of time, and this gets into some, I had a discussion kind of earlier with Dave here that relates to this a little bit, because if you go to like the AES library and you download everything on compressors, you're going to find at least 100 papers, and 95 of these things are going to be all mathematical explanations come up with and resulting in prototypes and things designed by mathematicians and computer scientists and really not audio engineers. And I think it's kind of important now, and it might even be a lost kind of art that's taking place, is because it used to be when somebody designed gear, they were a user and they also listened a lot, and they would modify the designs when you listen. So you can define everything, but the ear's ultimately the thing that matters on it. And if you're looking for a particular sound to meet some sort of ideas that you have, you go through all of this process. And with me, a lot of times I'll make measurements enough to know, okay, it's working, then I'll listen to it and modify it, and listen to it and modify it, and eventually make measurements again. And sometimes what you hear and what the measurements tell you, don't exactly jive on things. In that kind of process, though, accidents and happy ideas can happen. I just kind of read an article about, how the brain thinks and solves problems. and it was in Scientific American, and it's kind of an interesting thing, because we're all familiar with certain solutions to certain problems. But if you take those solutions to those problems, what kind of happens is you don't necessarily find the optimum or best solution for things, because you're already discounting these other avenues that you may never even address. And their example they were using was with a chess game, and okay, so I know the solution to that problem because I've seen it before and the brain's happy with it, and it prevents you from focusing on alternative paths from getting there. And one of the things I always try to do is find that alternative path, because partially I don't want to design something that sounds like what somebody else is doing, but also it's sort of a challenge, and sometimes that challenge works and sometimes it really doesn't work. But at the same time, when you take those paths, you can kind of get yourself into a little bit of trouble from the engineering point of view, where the mathematical approach may get you something that's more solid engineering wise, but without that listening and those other 3 points of view, if they don't merge, you may or may not come up with the most optimum solution for your particular problem. And then in all of this, you got to decide, well, what kind of technology am I going to use? Am I going to try and make this kind of gain control element or that kind of gain control element work, and what kind of amplifier? So there really is multiple kind of questions to it. One of the things that happens is like Crane Song's known for making a certain kind of sound and a certain kind of thing. Well, you want to preserve that, but at the same time you want to try and find, well, what can I do to enhance or improve or find a different solution? And then, of course, if you got that different solution, does it hold up to the test of time while working as in the studio with it? And some of us here are in unique positions, to kind of approach these things. And a question, related to compressors is, hey, everybody, you're using them too much. Is the bottom line. You're making problems for him while he's trying to master and make your record sound good.
Can be true. Oh, well, it's a complicated question, because compression is a great sound. It's a great tool. It's one of the most powerful tools in the studio, but it can't be reversed. So if you equalize something to make it brighter, you can also equalize it back to make it darker. You can bring it back to its original tonality. It's not true with compression. Expansion is not the opposite of compression. So if you overcompress something, there's really no way to ever come back to where you were. You cannot turn the omelet back into the egg. So if you get a master that's been really heavily compressed, especially the stereo mix heavily compressed, it can be quite difficult to master. It's too dense. Everything is kind of interrelated sometimes. It can also sound great. It's not to say that compression and a very dense, tight master can't be musical, but it is a fairly common problem to receive master mixes with a great deal of stereo bus compression, especially limiting, which I think is in some respects more destructive than overcompression. But it's not. The advice would be to not use it, and not. I wouldn't say don't be afraid of compression, but just be aware that you may be locking yourself into a particular sound that, if later you decide is not exactly what you were going for, it is not reversible the way that EQ is reversible. The other advice, and this is not about compression design by any means, but the peak limiting and clipping that a lot of people are using in order to generate a high apparent volume is really the killer. That's the thing that is difficult for, iTunes and YouTube and other formats. Doesn't translate very well. You can hear a lot of old records that have a tremendous amount of compression. I was just listening to ELO the other day. It's got a lot of compression, but it's got zero limiting. But it is 1176 to whatever, like crazy. Musical, big, louder than other things on the radio, but it's not clipped. And that distinction between high compression density and L2 limiting or straight clipping, I think is important to separate the two concepts.
Well, just one thing that strikes my mind when we talk about that, because that's what a lot of people consider it about. And if you look at the old things, I mean, it's not clipped, but it's all recorded to tape.
Mm-hmm.
So, and in the old days, when you're old enough to have tried that, it was like easier. Of course, we didn't have the loudness war, but we have old records that are recorded to tape in a high level and use the tape with maybe we're not even thinking too much about it. But that's interesting also to the concept of old and modern technology.
Yeah, well,
Because we don't use that. Some people use the technology still, but most people don't use that. And then they use awful tools to get into something that's similar, and then it gets worse. I think that's one of the really drawbacks of modern technology.
Now, what about your shirt?
That's about temperature.
Well, who in the audience has not recorded to tape ever in their lives? Anyone? Has everyone here yet?
Has anybody here listened to an all analog recording, not touched by digital in the past year?
Okay.
Oh,
Yeah.
cool. That's good, because the last 2 years I've asked this question, it's been 0. This is an improvement. Well, and the other thing that you gotta consider and it relates to the loudness wars, back in the days of 45 RPM records, the A&R guys believed that if the record played louder, you would sell more. So they pushed it, and if you listen to some of those 45s, if you go back, some of them are just horribly distorted. But they pushed it, did it to get, higher level out of it. So along comes CDs, and right now, George Massenberg showed me a study that somebody did. CDs are now playing 16 dB RMS louder than when they were first introduced.
Well, there was always a loudness war,
Yeah.
but
Yeah.
in phonograph record, there was a physical limitation where it was no longer playable, the needle would jump out of the groove. Well, the laser never jumps out of the groove on the CD. There is no physical limitation. You can have Raw Power by Iggy Pop, and that is 16 dB louder than any other CD. You can't listen to it for more than 10 seconds, but it's the loudest CD in the history of the world.
Yeah.
Because there isn't a physical limitation to digital. So.
Can I go back to the original question? I think it was about how we design
Yeah.
things. I think this is a good example of audio guys always digressing.
Of course.
well, there will be that, but this also
But
raises.
I think when Dave, you answered the first one very well. I think it goes without saying that we try to please ourselves as much as we can. And I come from, the background was that I learned how to make and design audio equipment because I could not afford to build or to buy my first studio. I had to build it. So I went to university, I studied physics and electronics. I thought wasn't that much electronics, it was more about how to make a transistor than how to use it. But I did it with the purpose was entirely to be able to build a studio. And I then went on to build, meanwhile I built a studio and I built several studios and I built equipment and I built things for myself. So a lot of my equipment, when I started at least, was because I wanted it myself. I built an equalizer that I wanted for myself that was accurate in the repeatability of the settings because it was hard to find one that was the same left and right, never mind two in different studios that will be the same. And I kind of developed from there to then start to please others as well as much as I could. But the problem with that is who do you ask for what you should do? And because you might get far more questions thrown back at you than you ask yourself. So you have to use yourself at least as sort of a mediator, or you have to decide. Someone has to decide what you want to do. I think that the biggest problem with designing equipment is not how to design equipment, but what to design. If you only know what kind of, let's say compressor, it's not that difficult to make that compressor, but it's difficult to know which one you should make and what it should sound like. But once you know that, there is always a way forward to do that. but it is difficult to know exactly what you should do. And when you then manufacture it and say, yes, you listen to it, seems to be less correlation with good measurement and good sounds than it is by sounding bad and bad measurement in some ways. So I think that because a piece measures well, it doesn't necessarily sound that great. It can sound just not much at all. And I think, but the problem then is if you listen to everything, is a repeatability also in manufacturing that you need to do. And one of the things, at least I learned from my university studies, was that you have to minimize the errors when you go ahead. And there are errors because of spreading components that you can buy. There is errors because of temperature. There are various errors, and you have to make a design that at least eliminates as much as possible of errors thrown at you. So good design is more immune to those errors. But we're at the level now where we have to measure very carefully. And I think you can't always trust your ears, and you can't set every setting. You have to use also some sort of production measurement or to verify that it still is okay. But for me, the biggest problem sounds maybe arrogant, that the biggest difficulty is not how to design it, but is what to design and what it should sound like. That is for me the key sort of question.
Yeah. Well, see, in manufacturing, there is the production test issue, which is what you're referring to, and that's a whole another issue besides the design aspect of it, because there's no way if you're building 300 or 400 boxes of a year, you're going to be able to sit for an hour with each one and play with it.
You might have a cold that day as well, so you might not even be able to do it.
Yeah, or you're just plain burnt out or tired or whatever. You just so you have to really deal with some sort of production test with it. But the design choices, some of that's just sort of from your gut and from your heart.
Yeah.
But some of it also, because some of us are still active engineers and doing things, and it becomes, I'm having a problem making this sound right. Okay, so you get a next project. Well, gee, I'm still having this same kind of problem in this same manner or a similar manner. And that starts suggesting, well, if this is the problem that needs to be solved, and of course you gotta have reasonable confidence you're solving a problem that's just not unique to your room because your speaker system's screwed up or something. But it's like a good song when you record. It tells you if you're sensitive to it as to what you should do and what kinds of sounds and how you should EQ the guitars. A good song will tell you this, and you'll be able to feel your way through it. And of course the songwriter will come in and say, do this instead, but it will still tell you a lot. And if it's well arranged, well recorded, and well played, even when you get to mixing it, a lot of it will kind of just fall in place and work for you. You won't have to be trying to create dynamics and spend 100 hours editing and fixing it and solving those kind of mechanical problems. But the music does speak to you. As a designer, as a mastering engineer, it has to speak to you.
Yeah, well, it used to probably be easier to have the music speak to you when it was all played for you. Sort of, when I produced a lot of records, and I used to go into rehearsal rooms with people. You work for months before you're starting to cut the tracks, so you knew inside out what it would sound like, because I worked with musicians, very little with program stuff. I almost used a different word and stuff. And I think that the problem is that it's harder to get a picture of something that comes up in such small fragments to you. It might just start with one boom, boom, and a little bit built to it, and you haven't got that picture. The only one with a picture is the songwriter, and the best modern things are usually done with a songwriter who controls everything, who gets that sort of cohesive kind of thread through the production. But it's very hard to come in as an engineer and not hear a song, but hear just little things coming out of a loop coming out, maybe where they're still writing it whilst you're supposedly mixing the song. But in the past you could have them play the thing for you and listen to and make decisions, and then things fell automatically into its pocket. As far as equipment is concerned, yes, then you know you know what works and doesn't work, because you have that picture of what it should sound like, and you think, I can't just get to this thing. with what's in the studio or what I have, and then you start dreaming about maybe designing something that could do that. And that will be sometimes your best things that you've done when it came from that kind of background.
Yeah.
I've worked with two major designers in my career, and a lot of time their own personal ego got in the way of the ultimate design. Like they would just keep messing with it till a year later this thing is just so complicated and wacky it bore no relationship to what anyone actually even needed or wanted. Being in Hollywood, being in Los Angeles, we're really local to a lot of mastering engineers. I took the first Massive Passive down to Dave's studio to Dave's at A&M, and he listened to it for a day or so, and when I went back to pick it up, he played me a Masalek EQ, and he said, "This is how the bass should sound." And I'm like, "Yeah, you're right. This prototype sounds terrible." So we rely a lot on local customers to really give us their feedback, and also I'm in constant touch with people from all over the world who are telling me what they want, and I'm listening, and we cruise on the forums, so I'm digesting a lot of information and making a decision about what we're going to produce next. The art of what we do, I think now, is to know when we're measuring something how that's going to translate audibly. And we have transformer winding facilities at Manley Labs, and one thing that's really great is to make creative choices. You know, you measure something, you say, okay, that measures better, now let's listen to it, and then try to get the emotional feedback from that audibly. And maybe it's not there, and maybe you want to inject some low frequency saturation or something to make it sound fatter or bigger or something like that. Those are creative choices we can make, but we're constantly going back and forth between measured, empirical data, stuff you can measure, and listening. And not just my listening or Dave's listening, but lots of people's listening, say in LA. It's a real advantage I think we have.
Just one subject I thought of, which is not really much around us, but around the business in designing to a price.
Oh yeah.
Oh, yeah.
Because if people should decide without really knowing, and you look at promotion or whatever material, I mean, a lot of people tell you that this is fantastic and the price is a half. And I don't know, from a designing point of view, I think we should maybe mention that, because I think it's pretty important to
No, I think
be
that
able
a
to
lot of
evaluate.
people will tell you, I love this, but I can't afford it. It's the most common comment.
Well,
Yeah,
we just
very
came out with a unit, a combo strip that's half the price of the big one that's been in existence for more than 15 years.
Yeah.
And, that was the purpose of the design, was let's make a channel strip that's half the price of the one we had before. Well, how are we going to do that? You can't just go put in a whole bunch of chromey parts that are going to be unreliable. You can't just throw stuff in there without testing it. There still has to be, you have to match components. You have to eliminate the errors. No one's going to tolerate a bunch of errors or a bunch of crummy sounding, feeling pots and all that. So we had to get really clever with the layout and how fast we put it together and try to eliminate as much human labor as we can, just make it fly together. That's one way we were able to save some costs. And also, maybe the other unit's got 5 transformers in it and this one's got 1. That's definitely, you save a lot of money with stuff like that. So we use technology, and there's less expensive technology. There's transistors. They you can trick a lot of circuits to make them sound exactly how you want, and to give the kind of harmonic structure of something you desire, whether it be a transistor circuit or a vacuum tube circuit. There's a lot of things we can all do to play with those things to give something that'll sound a certain way.
Yeah, see, with that, surface mount versus through hole. The reality is things like through hole transistors, they're going away. There's still some around, still some of the power stuff. Fairchild's pretty much quit making a lot of them. National Semiconductor, which now is owned by TI's, quit making a lot of them. I think.
Do people know what surface mount versus through hole means?
Yeah.
Okay.
And the thing about surface mount.
Slightly exotic.
Yeah, it could be a bit exotic. The thing about the surface mount, there's a learning curve as to how to do it, so it still sounds audibly correct. There's just mechanical issues, but it's a great labor savings device. And, you know, and this is something that all of us as designers are gonna really have to consider here,
Yeah.
because with the through-hole stuff going
Yeah.
away. Well, the whole of the pro audio industry, if you go to a semiconductor manufacturer and they say, you're not even a sliver of a line on our pie chart, why should we even bother with you? When they can make cell phone parts for Apple. You know, and they got some accountant making the decision. Guess what they're gonna do? They're gonna make stuff that runs on 5 volts, and we need stuff that will take 50-volt supplies or higher.
Yeah, I can. There's another point there. If it is a hell of a lot easier to prototype in your lab something which is through hole than surface mount, and it is really if you need to with capacitors and other things. If there is any, I don't know. Fortunately, they're not through hole. The filter capacitors, but it would be virtually impossible to match them because it's a bitch to put into a hole or something. Those. But the other thing is that the semiconductor thing that they are discontinuing components weekly or daily almost. I mean, it's every now and then you just get a notification that they discontinued this one, discontinued that, and the quality control from some of the manufacturers have gone down dramatically. So, in fact, some of it, like for the noise character and noise other things, it's very difficult to measure some of these things because they might just there's noise that doesn't really show up unless you measure it for a very long time. There might be little sort of squirts of noise coming out, so you really have to listen to things
Like
again
tubes.
to do that. And so it's not easy today to make your choices yourself. You have to live with the choices that others have made for you for commercial reasons.
Yeah, there's a dual transistor Analog Devices makes, or used to make. We were talking about this, called an MATO2. We were paying $5 to $6 range for them, you know, in quantities 100 to 250. Well, they actually quit making them about 4 or 5 years before anybody really realized it. They had that on the shelf. But they changed the manufacturing process, changed the part a little bit, you know, not really bad as far as audio is concerned. That quantity now, they're $20+. And the only reason they're making that part is because it's used in some medical equipment and the military uses it.
If it was audio only, they would be discontinued
Yeah.
completely.
Yeah, it'd be gone if it was audio only. And if you make a discrete Class A preamp, transformerless, or maybe even with transformer, that's one of the few choices there is for a part.
Yeah.
Excuse me, coming back to the CMS issue, would you say that they generally,
There's a microphone.
coming back to the CMS versus through-hole issue, would you say that CMS sounds worse than ordinary components, or?
Not necessarily. There's a learning curve dealing with surface mount. The common cheap resistors tend to have kind of a high third harmonic distortion content issue with them. And they're known as thick film parts. And the thin film parts, which are made by a different process, you know, actually are pretty good. And this is one of the things you learn. Capacitors are a real issue with surface mount stuff. Getting, you know, there is no polypropylene capacitors on surface mount. There is no polystyrene. Well, polystyrene caps would melt when you refloat them anyways. And yeah, it'd be pretty much impossible. So we still have to go back and rely on some of that stuff. There are things as a designer you need to learn to make it work correctly. On the other side of that, when you get into converter chips and logic and that kind of thing, because the packages are smaller, there's less inductance, so there's less bad stray effects due to the package size. So there's some advantages on that part of it.
We have one more question.
Couldn't you all together find a way to have some weight so the manufacturers keep on making those components?
Yeah, sell millions or buy millions of everything.
I
That's all.
had this discussion with that corporation. about a 24 volt op amp. At the time, the Burr Brown / TI part they were making didn't work. They said it worked. It runs through our test. Well, why does it fail within the first 24 hours in the unit? And we put in new ones, and those fail in the first. I don't know if you went through that too.
2604.
The 2604 mess.
Yeah.
Yeah, it was quite a mess, and there was a guy. God, I can picture him. Can't put his name together at the moment, but he had worked for Analog Devices, knew how to talk to the engineers at TI about it, and said, well, how do you test this? Oh, for about 5 milliseconds. And he said, oh, why don't you try testing it overnight? And they came back and said, oops. You know, and they were making millions of these things. So when I talked to that corp, you know, because they were asking me, what kind of part would you like to see? And they do that with all of us, because, you know, they're a fabless semiconductor company, and they do some good stuff. Well, okay, op amp. Well, we're going to need a minimum sales of $1 million in this part. So how many in the industry do you think are going to buy it? And it roughly starts working out to be $10 to $20 a part in quantity for us. Doesn't work.
Audio is a very small market.
Because some guy just winding transformers the old way, or reissued some rare tubes and stuff, but concerning semiconductors, it's not working.
Yeah, yeah.
Well, it's
Transformers are
tubes,
easy.
the same story. I
They're
mean,
small companies.
any tubes that we're buying now, it's the guitar amplifier business that's really determines what tubes the like 3 or 4 manufacturers in the world are left building. So, you know, if it's a 12AX7, cool. If you want some other exotic tube, they quit making that 20, 30, 40 years ago. Because audio, we're nothing. We're a pimple on their butt, you know.
Yeah, and there was
Compared
this
to guitar
a
amps.
discussion that took place at AES one year, because you know Greg from Pendulum.
Sure, very well.
Yeah, and because he worked at Bell Labs doing semiconductor research in manufacturing, and we kind of looked at it, and you can actually go out on eBay and find pretty much everything you need to set up a semiconductor fab. What kind of shape it's actually in, who knows, but you could actually do it. However, it's really not something that you want to be doing yourself. The chemicals
Toxic.
and materials involved with this stuff are extremely nasty. Arsenic, being one of the common things in semiconductor doping. I had a student when I taught who went to work for Honeywell building semiconductors. And you know, what they use for cleaning the stuff, it's not phosphoric, hydrofluoric acid. Okay, so hydrofluoric acid is one of these things that, okay, you handle it in a glove and everything with gloves. And if you spill it in your glove, you're not going to get to the emergency wash fountain before.
It's like an alien, where it's the alien's blood would drill right through the spaceship. If you
Yeah,
remember
yeah,
that
yeah,
movie,
yeah.
that's
Yeah,
what
yeah.
hydrofluoric acid.
You would not have a hand by the time you got to be able to safely remove the stuff. So that's the kind of stuff that's involved in doing that. And let's see, ion implantings, you know, actually a linear accelerator, and on and on. And you have to be able to do this in a vibration-free
Clean room.
And vibration-free means, like, you go to Silicon Valley and Intel and the other fabs that are there, they are on spring-isolated, shock mount-isolated columns, so even if there's a major earthquake, they don't feel a vibration in the building, because the traffic driving by would be enough to screw up the parts they make.
Okay, thank you. And actually, it's kind of related to my next question, which was about the state of affairs of analog components. Like, we know technology is improving, and I think, I mean, I recently heard like analog gear that, I mean, it's really, really good. So I was wondering, what is your opinion on, are there more improvements that we can see towards the future, and what are the components that you might have issues with that might get worse, and how do you see this?
We just, you know, do you all know there with power supplies, there's a thing called linear power supplies where you use a big transformer, well, a transformer, from the power coming out of your wall to make other voltages, then you rectify it, and you get that all ready for your circuit. And then there's another thing called switch mode power supplies, which are real little things that you see, like this little brick in front of us here probably. So there's some real advantages to a really good switch mode power supply, namely, you don't have to change the voltage to ship all over the world, and and they're lighter and they're supposed to be cheaper. But most of the time they're really noisy and really horrible. So in our case, we decided to hire the worldwide expert who knows the most about switch mode power supply design than anyone in the world, and he designed for us a really great, fabulous, built for audio, designed for vacuum tubes, switch mode power supply. And that's really exciting for us because it's actually superior in every way to our old linear supplies. It's quieter, lower impedance, all the rails are regulated. It wasn't any cheaper, unfortunately, but all the gains are we're so excited about this. So that's a new technology for us. I mean, we're dealing with antique vacuum tubes, and then we've got the latest and greatest, coolest power supply design on the planet.
And it sounds good too. It has the
Yeah.
sonic advantage.
So that's one case of looking towards new technology and getting that worked into our antique audio designs. But it works.
Yeah, yes, see the other, and I did the switch mode thing for the Spider, and we actually, no, it was not cheaper. it was, but it's twice as much power as it used to be, and it's actually quieter.
Mm-hmm.
So the guy that did that for me was a former student who did power supplies for missiles for 25 years, so he kind of had a handle on, what was
He knew
needed
what he was
for
doing.
doing it.
But it's also getting necessary. But what we see is that some of the stuff we have been building for 30 years, and we had for many years the same people. We don't do our own transformers. We had a good company to do that. But suddenly the good company was bought by a bigger, not so good company. And suddenly it got worse. And then the guys who built the transformers, because it was the same guys, they got old. They went on a pension. And the new guys, suddenly it was all a mess.
Yeah.
So John Peterson, who designs TubeTech, he had to go and redesign the transformers. The company was not good enough to do that. So that leads you into finding, that's the troubles we have with a lot of stuff, like we discussed before, quality falling down, the stuff gets worse, they want you to buy more, and you cannot rely on it. So it's we try still, we could just done is kind of conservative, to do it the same old way, but that gets harder and harder every day. So there's a need to look for clever, modern solution.
Yeah, and see, a thing with surface mount too, is you can make the circuit smaller, put the parts closer together, and in a given space you can reduce the interaction between various parts of some of the circuits, because you can keep critical things away from each other because each of the circuits are smaller. And with some other tricks, in circuit design you can actually get improved performance over through-hole. But it's sometimes a little bit of work to get there, and sometimes, like I said, you lose your hair trying to do it, because you'll have this prototype thing and it works really, really good, and you plug it into the actual product that you're designing and you go, doesn't work so good anymore. Things happen, and you just kind of have to learn how to solve those problems.
There is another side to it as well. For analog equipment, we use a lot of, we do use different front panel or sometimes back panel, but front panel technology as well. We have hands-on switches, we have hands-on potentiometers, or we control things directly we don't do it through a computer. So by and large we don't do that, but mostly we use either rotary control or push button or toggle switches, and they are harder to get hold of as well. If you look at rotary switch manufacturers, they will make a switch that has enough position, say a 24 position switch that has got the 15-degree indexing, or if you go to the next step up where you might have 10-degree indexing or 12.5 degree or whatever it might be, there are only so many, maybe that many, or not even that many manufacturers in the world that you can go to. And you can't then thump your and say, if you don't do this for me, I go somewhere else, and they laugh at you and say, who would that be then?
Yeah,
You know, and it could be that we own them too.
yeah.
So
yeah.
it is very difficult, and the quality is not exactly going up on these things. If anything, they're going down.
Yeah.
And the problem is, so here you have a circuit maybe that works beautifully, and the feel of the switch doesn't work so well. It's like you have 3 switches and they all feel totally different. That we talked about before earlier, that you know the torque is not that it's grindy at places maybe, or it might be bouncing, so and it lasts for like 3 weeks and then you get sort of noise from it. So you're stuck with only so many physical sort of components that you use, sort of that the people who buy it will actually see, never mind what's behind the panel. And again, with surface mount, you could make very small circuits, but the box that we sell will still be determined by how large the knobs are and the controls on the front panel. You know, how small can you make a meter and still be able to read it, and how small is the knob that you turn without being ridiculous. So you have it becomes quite a large box. So for that reason, there isn't really a problem necessarily with the size of the surface mount. It's just a production cost as well, that to put this thing together might be cheaper with labor-wise with a surface mount. But as Dave said, it's very difficult to go from one, you know, after all these years we know sort of how to do a circuit and make it work, and we know that if I do this, that works. Surface mount is, oh God, all things now is different. What is this going to be like? How long will it take to perfect that? It needs almost a new designer who's grown up with that to think sort of instinctively about
Yeah,
it.
and we could add ROASH to the list of frustrations, but
It's a lead-free thing.
the lead-
Another thing, you know, as recording styles have changed over the years. Say 20 years ago, I'll take the same piece of equipment we've been making. We had a stereo input control, so left and right channels were on the same potentiometer. And that potentiometer had a 20% tolerance rating from the manufacturer. So if it was a 100K value, 100 kilo ohms, it could have maybe it's 80K or maybe it's 120K or something like that. So left and right would be off a little bit as you turn the pot. Maybe left channel would be a dB and a half louder, and then kind of catch up, and maybe it'd be down half a dB here, whatever. People didn't really care that much about it back 20 years ago, because they were really just listening, and they were watching meters bounce, but it was a different thing than today. So if it was off a little bit and you could hear it, all right, you can hit the output control up a little bit, and you'll have the center image where you're supposed to. These days, what I see going on is a lot of people are really relying on the computer screen, and they're watching the meters on their DAW, on their digital audio workstation. And they're looking at numbers on the screen. And so we start getting calls. Oh my God, this unit, it's a dB louder on the left channel. I want a new one, it's broken. It's like, no. And then, you know, a few years go by. Now we're matching the pots, we're taking them apart, we're measuring them, we're trying to get them to track within a half a dB, and then the calls are coming in. Oh my God, the right channel is louder by half dB. And then we're doing this and that, and finally we just moved to a switch with 1% resistors. And it's terrible, because maybe you want to be right in the middle, but the problem is that our customers, are recording with their eyeballs, and you cannot hear that half dB difference anyway, you know. So when you ask, you know, well, why is that thing so expensive? Well, it's because we had to do all this work to make this thing, you know, track perfectly like a computer plug-in, but it's not a computer plug-in. It's analog equipment. It's really time-consuming to select components and match things to make it as perfect as possible. And so, you know, remember that we're in the audio business, and we're supposed to be using our ears to record, not our eyes.
We had the same thing.
That's what I'd like to say.
We had exactly the same thing with the multiband, where we also people looking at the figures, and it's exactly the same
Yeah.
thing. And I mean, I've been working with that, and people who are more old school, they listen to it, and if it's a little off, then they find a way to adjust that. It's nothing. But then people measure, So we had to put in this kind of joke knob, which is like 1 ± 1 dB balance knob, just to make these guys happy.
Yeah.
Well,
It doesn't make sense.
yeah, it's actually
It's
gotten,
ridiculous.
it's gotten worse than that.
And it
Yeah.
degraded
Okay,
the
okay,
unit.
so we all got
I didn't make
workstations here. How many people do FFT measurements to look at things?
Watch the spectrum analyzer bounce around as you
Yeah.
record.
Oh, good, nobody in here, that's a good thing, because,
They're
because,
not
because
there, someone's lying.
most people,
Someone's-
yeah, probably, but, because most people who do FFT measurements don't have a clue as to what it means. And they'll well, there's this 16K spike here, and I can hear it out in my driveway when the system's left on and I'm coming home. Well, at what level it is? Well, it's about a minus 130 dB.
You're right.
And it's like, but that's the kind of things, I get emails like this all the time of, yeah, but this measurement says this, and it says the noise floor is like minus 75 when I turn on all of this stuff. Well, can you hear it? Probably not. Does it really mean anything? Well, maybe not. But I see this, what is it, Mark of the Unicorn, they give you an FFT thing, I think, with their box. There's a
I think
couple.
it's thrown in free with every product nowadays. You get a
Pretty much
FFT
every
of
one
some
of
type.
Yeah, because most people have, they think it's the ultimate measuring thing, and it's like, unless you know how to interpret it and realize how it lies to you, because you can use it to show spectrum of two different things, and it will match, and they'll sound completely different.
But then if you, like, with the sound, that people forget to listen, is it a pleasant sound?
Yeah.
Does it make
Yeah,
them
well,
happy?
there
Does
is-
it create some joy?
The business is obviously split up into different areas, sort of what we sell to and what we do. I mean, I come from recording, mixing. I've done a little bit of disc cutting and mastering, but a lot of recording and mixing. I love recording more than any of the other things because this is the creative part of it. The rest is kind of housekeeping after that and making sure that hiding all the what you didn't achieve maybe doing the recording. I don't know about you. How many of you are mixers? Are mixing records or songs? Because what we're talking about now has become very, I understand, very important about the recallability. Because when you're mixing records today, you're used to that within your Pro Tools or whatever you use, you get an exact recall of everything except the analog output gear that you're using. And if you can't, I get that a lot from people. The weak link of being able to put in that, and at a cost, again, you don't get paid for what you used to. You have to do things quickly. You're supposed to be able to put this back in again and only make a minute change, or having it exactly like before. The only difference is that you might have redone one of the backing vocals or something on it. And if you can't reset the output gear, i.e. the analog pieces of equipment which is not under computer control accurately, the mix will fall apart anyway. It won't sound the same. It was different, but the nearest you got in with the all analog was like the SSL Total Recall, which was not precisely exact. It was sort of roughly the same, but it wasn't. You knew that it wasn't going to be 100% okay. Therefore, you were less critical about the output gear. But today, if you're using computers or if you control mixing, you're used to that everything is precisely the same as before except the output gear. And if you have potentiometers, never mind that left and right, never mind that, but can you set it at about 10 o'clock, and maybe that's plus minus a few dB or even 1 dB. That will make a difference to the mix, won't it? So that is a challenge today, and that maybe makes people focus more on what's wrong with being able to get the same signal as before, because it actually is a problem, a real problem, and which has nothing to do with whether you like it or not. But so there is that side to it too.
But then that way of working suddenly decides the quality people are using, because they fall into, well, then we use these plugins, because then we can record.
Yeah,
and then
yeah.
suddenly our beautiful, nice vintage or whatever analog equipment is not being used.
Yeah, but I've got a friend who's got a mix room, this beautiful mix room, and he's got a huge Pro Tools rig, and he must have about 100 odd converters that are just patch points. So he has an I/O for every piece of analog equipment he's got, which is probably in the region of 100 channels worth of analog equipment. And every one of them has a dedicated D to A and A to D. So it's plugged in straight, and he does all the patching is done with the computers. He never patches anything physically, but he has to reset those. And they have to be recall sheets. He loves step controls, I tell you, because even though he's in between maybe the ideal, at least it will be the same next time.
But I must say, I've done with my work now, doing more promotional work, I have more time than when I was running a recording studio. So I have time to take projects. I've done a little research into people's projects, well-known mixers, with stuff known for being pretty good at their stuff, also with records being mastered for a lot of money. And I have several projects I travel with where I take everything out, I remove every single plugin, and make a very, very simple mix, and treat it with whatever simple mastering tools. And very often, as a matter of fact, all the times I've done it, the results comes out much better, which is weird, because then my solution was simple, with using few right tools, and then it was not that hard. Then you, of course, you have to record by taking a snapshot or something. But it's crazy to see how much people get into using, because it's easier on the computer. Click plugin, click one more plugin, this one, and then it adds to up a lot of digital processing, which I feel I can prove that's not the way to go. But a lot of people do that.
Yeah, but
Even
it's-
very high level pro.
But that is just easier than it used to be. I remember well, sort of in the analog where everything was analog. I mean, it might be a digital tape recorder in there, but the whole room was analog. It was going through analog racks, like sort of a traditional control room is. And the bass, as soon as the bass drum hit, was sort of, or the drummer hit the bass drum, you could see flashing lights going around the whole room. This thing was going through all these boxes. And if you compare the beginning of what it came off the mic and the end result, wasn't that much difference. But still, it had to go all through all this, possibly because it sounded much more consistent before there were any samplers that you could use. But still, we can talk all day, but the people who do that are the ones that have to change. If they like to work like that, they'll work like that, no matter what we tell them.
Well, I threw a guy out of my office the other day who was trying to buy some more gear, and he didn't quite have enough money for an EQ that he wanted or whatever. I'm like, you know what? Just stop buying gear. You haven't even recorded one note with this stack of gear that you bought 2 months ago. He's just been on a equipment purchasing mission because he's got a lot of money, but he's never recorded anything. I said, go learn how to record first and then get on the gear. You know, you don't need all this gear to record. You need to learn how to record, get some skills.
Yeah, there's a couple things that happens with the plug-in scenario. With some people, it is, I can do this, so I should. Okay, and they do, and when you get their mix, they bring you their song for you to mix. You remove all the plugins, because the same thing is true in the digital world as it was in the analog world. The less crap in the signal path, the better it sounds. And that still really, really holds. The other thing is, the reality is, the compressor plugins don't sound as good. The EQ plugins, even the best ones, can be workable, but they really don't sound as good as a good external analog EQ. They just don't. And if you do real critical listening, and which is this is a whole nother discussion, accuracy of monitors, so you can actually believe what you are hearing, and we could get into this for hours on that. And with a side note, subwoofers don't work, so you got to have full range speakers, and it also interacts with your acoustics and all these things. But if you have a really accurate monitoring system, which is what you need first, so you can actually know that you can believe what you're hearing, you will hear these things that the more crap in there, the crappier it sounds. And you'll find that the less processing you do, the less compression, You know, if you got a nice acoustic space, you won't have to do as much EQ, and all of a sudden you end up with a mix and it sparkles and it shines and it has space in it, and Dave goes to master it, and it's wonderful sounding afterwards, as opposed to bringing him square waves with too much bottom and expecting him to fix it.
Yeah, I think that, again, it doesn't matter how good your speakers are, it doesn't matter how many good compressors or how non-compressor you have, you've got to know what you want it to sound like, not just knowing what it sounds like. So when do you know that it's great, or when do you know that it's wrong? And it's only because you know what it should sound like, isn't it? And I find that is one of the big things that people haven't, I mean, they lost their own taste. Maybe they just are followers, not leaders in that sense.
You go out on gear sluts and you want to learn the opinion. Well, gee, I need to compress all my drums. It's like, why?
Yeah.
But that's what Gear Sluts tells you.
Yeah.
So the people come in to the stand at the show at NAMM or AES or whatever. Well, I need enough compressor channels to handle all my drums. And it's like, why do you need that? Well, because that's what it said on Gear Sluts. Well, you know, that's not really the step about making a good recording. Let's figure out what you really need and what you're really trying to do first. And then we can determine whether you actually need a compressor for your drums or not. And being a compressor manufacturer, that's sort of a weird thing to tell somebody who's looking to buy them, but, you know, that's the reality.
But what's wrong with one good compressor instead of 10 shitty compressors?
Well, then
Sometimes that's a good solution.
Yeah.
Sometimes you don't even need one. You just need it to get it. You know, it's not necessarily, the presumption isn't that you need to compress. You only compress because you need to compress, you know, not because that's what you
should be doing.
You should be doing. That's
Yeah.
the one thing that is going wrong with a lot. This is what they read about something and you don't know who said that, why did they say it. So, I mean, for any kind of music, classical music, jazz music, pop music, hip hop, what music is it? Now we compress with 10 compressors.
But if you look at pop music or soul, old souls, reference for a lot of stuff today, it has been heavily compressed in a simple way.
Beyond
so that's kind of the thing a lot of people look at and wonder how did they do that?
Yeah, well, it's not music anymore; it's technology at that
Well,
point.
they only did it because they could. Is what's the answer you
Oh,
get?
yeah,
And
but
that
that-
is the real. That's the only true answer.
But the way they could do it is not the way people do it today, because they do it on emulations, digital emulations of what they did.
But I mean, go back and look at the consoles there. I mean, you've got a compressor in every channel.
Mm.
We've had that since what, early 70s. That would be consoles with a compressor on every channel. Did that mean that everything was too much compressed? Sometimes yes, sometimes not. But I think that it's what the music. I think the lack of all this is that the music doesn't dictate what you do. Sort of, it sounds to me like, you know, everyone has an opinion about how you should record without relating back to, but what does that song or that piece of music dictate that you do?
But
That is the
another
biggest
thing that's
difference.
interesting when you mention that, I think that goes for us with what we do is that particular brand of console in the 70s. When you had facilities, suddenly you had recall, suddenly you had computer mix.
Yeah.
But you also had a console where some of the money for the sound making part of it went into the control circuits. And suddenly the EQs didn't sound well, and that was when the Pultecs took off. That was because of those SSL series, because people couldn't get the high frequency sounding nice, so they found that all vintage tube stuff. And now
Yeah.
that's been, we see exactly the same thing happening now with digital. When young people who never heard the beauty of a passive EQ, the simple stuff you can build,
Yeah,
they go
but-
nuts because they never experienced something as pleasant as that.
There is another thing as well. If you are in a studio and you have a console where you can see clearly where the knobs are pointing, you can see that everything is whacked up or down like this. Perhaps the singer or whoever will look at that and say, "Is that my channel? Why are the controls so weird on that EQ? Is that what you do to my?" But when it's in the computer, you can't really see what you've done. You know, you might be, but normally it's hidden away. So you can't see. It's not so intimidating as it will be with analog when you have extreme settings on everything. So the controls on an analog piece of equipment does two things. It changes what it is, but it tells you what it's the display at the same time. You know, and this is part of I think, that you can do too much easily on plugins and other things because you're not quite so aware of what you're doing.
Thanks. My next question is about, what I've seen is a lot as a teacher is that students nowadays, they understand less and less about signal flow because you have Pro Tools and you just click a button and signal is there. So I wonder how that relates to the analog gear. How many people, let's say they want to do mastering, properly calibrate their system? Do they know what the headroom is in the equipment they buy? Like, what is your feeling about that?
Well, I think it's certainly a problem in a lot of cases, and gain structure didn't go away because digital audio workstations appeared. Operating levels are still important. We were talking earlier about people running excessive levels inside the workstation and seeing a lot of red lights on the meters. You'll get a better mix, and you'll get a mix that actually masters better if you run your levels low. And if the peak level that you present the stereo mix at is at -20, seems very low. It'll sound much better than a mix that's peaking at 0 all the time. There's a phenomenon called intersample peaking, which is actually causing clipping inside the workstation itself, even in floating point frame. And you can have, I guess you could go back and say that gain structure never went away. It became easier to operate at the wrong level in digital, where in analog you might be fighting headroom clipping, noise floor. There was more of a sweet spot. But digital also has a sweet spot, and lower is better than louder. And it's easy to do an experiment with your workstation because you can master trim everything down and see what you think. See if that mix where you had a lot of red lights blinking everywhere and the plugins were clipping and the Pro Tools meters were in the yellow to red zone, trim everything down a lot. Trim it down 20 dB, whack the monitor volume up 20 dB, and see what you think. I think it's a very illuminating experiment to try. Costs nothing, takes 5 minutes, and see what you think. Now, as far as operating levels in the analog world, that hasn't really changed. The headroom of analog gear has been pretty much the same for a long time. You might have tube gear that has very high maximum output levels, yay, tubes, but at the same time, attention to gain structure throughout the signal path is just as important now. Digital has actually kind of made it worse in some respects because the idea of headroom and operating level is confusing to a lot of engineers, even experienced engineers. You'll find a lot of misconceptions about what is, what do I call 0? Do I call 0 -18 for +4 dBu? What is my operating level? What is the right operating level? And I think probably as an instructor, you've come up against a lot of misconceptions, a lot of need to define a little more accurately what operating level is.
Mm-hmm. Yep.
What do you find when you are teaching?
Well, not only as a teacher, but also, for example, as a studio and having interns come into the studio and they not fully understanding how you calibrate an analog signal chain, even that. And yeah, I just, there seem to be a lot of misconceptions about, well, basically what they think is you just need the analog gear and you just plug in the XLR, have the XLR come out and not worry about it as they think in digital. I think that is one of the main key aspect is that they don't even think about, okay, it needs to be at a good level. And I just think the fact that they forget to think about gain structure, I think that's the main key. Not to know really what level to put it at, that is the next step, but to actually just forget that it's necessary.
Yeah, because in analog studios, in a studio like you have next door, any of these rooms, there really was a sweet spot for the operating level, and you would always find that there was a place the console wanted to operate at. Now maybe in that old SSL, it's with the stereo bus meter slamming. When I go in most SSL rooms, when you walk in, it's pretty hot. There's some saturation effect in stereo bus. People like the sound of it, but there is a operating level for almost any piece of gear that it is happier.
But isn't it also, I've been wondering, I'm not that technical, so I don't know how that has evolved, but I've never been able to find any information. So in the old days, it was like first generation digital was, over 0. Goodbye. But now you can just crank it up, and whatever is made, how are the systems made to act? Of course, it's not analog, but they just distort in an awful way. So you can have red lights all over the place without having horrible noises. It just sounds shitty in a different way.
Sometimes there's horrible noises, and I'm wondering, how did anyone responsible ever release that record that way? There's a Carpenter's Greatest Hits that was actually Dave mastered the original one like 20 years ago, or on CD, sorry. And there was a re-release of the Carpenter's Greatest Hits that came out just a couple years ago, and Karen Carpenter, her voice hits like, there's noise that comes on the peaks of her vocals like, you can hear that. It's like, and this was mastered by a very experienced person. I'm not going to name names, but it's like, how can they release that sounding like that? Or how you listen on the radio and the limiter is just destroyed. The radio limiter has destroyed it. So how can you record something that's so hot and distorted, and then when the radio adds its processing to it, the record gets completely trashed. I mean, we're driving around. Dave will say, "Where'd the snare drum go?" And I wasn't even focusing on the snare drum, but then I start listening. It's like, oh yeah, you can't even hear it because it's over limited.
Yeah, see,
you have to learn how to listen
in the
too.
digital world, okay, operating level, and those of us who have did the Avid TDM thing. Okay, so in that world, the maximum signal was plus or minus 1. Numerically, was the range that it had to be in. And that kind of forced, if you were paying attention, you into a certain range. Because if you went beyond plus or minus 1, you clicked and it was a bad thing. But once we got to floating point, what can happen within the channel, not the recorded part, and not the output part, which ends up being two separate things. But through the plug-in chain with floating point, it can be plus or minus 2, plus or minus 3. Well, a lot of this code was never really designed to really go beyond plus or minus 1, and things were done to make it so it tolerates that, and and an EQ might be okay, and some other things may not be so okay with that. So because of the floating point, it allows you to actually operate at a much hotter level within the plugins than you really should. And in theory, the floating point mixer can kind of take care of that, but you may have already done some damage, within that plug-in chain because of the hot levels. But it still comes down to when you go to output the audio out of the thing to your D to A, you still have to be within the plus and minus 1 range.
The world is fixed point.
Yeah.
The world is fixed point math, not floating point. And as long as, whether you got 64-bit floating point audio or 32-bit floating point audio, it doesn't really matter. You still have to gain trim that down so you're still within that plus and minus 1 range. And in doing that, okay, so we got too hot here and we had too much gain here and too much gain here, so we got to pull it down here and we got to pull it down here, and then maybe we got to trim it for the output level. Gee, we're starting to add more processing and more multiplies, and every time we do all these things, we deteriorate things. So you have to be really careful that even though floating point will handle it, don't go beyond plus or minus 1. Treat it with either, maybe 20 dB down doesn't always work, but at least leave some room in there because things just get unhappy. The mathematicians will say this works. See, here's the math for it. It works. Well, why doesn't it sound right?
But you have to listen,
Yeah.
and you have to know what to listen for. And sometimes I didn't innately know how to listen for when I first started in the audio business. I was testing compressors, and I'm like, I didn't really get it. Like, why would you use it? And someone had to explain to me, and maybe play a certain track and say, now listen how the snare drum does this or whatever. For me, at least, sometimes it's not innate what you're listening for, and that's why hanging out with other engineers and other people who know to pass that knowledge to you is really life-changing.
The part of the question was, wasn't it, in the analog world, wasn't it?
Yeah, they-
Yeah.
Yeah.
So what you have to think about is if you come into a converter if you have an analog chain, on the whole, I think it's, as long as you don't crank things too much, it probably works reasonably well by just doing XLR to XLR through it. With our pieces of equipment, probably has enough dynamic range to cope with that. You don't have to sort of fiddle with levels. You can just say, well, as long as I have nominal level through, unity gain to begin with through, it probably will work. But when you come into the converter and then what happens with sort of the level, you have bizarre requests from people. One wanted me to recalibrate. I do an analog limiter, which can sound good, but it can sound horrible. But it will not go over after it's a brick wall thing. And they wanted me to recalibrate that to plus 26 dBu instead of maximum plus 20, because I was so stupid to not understand that if they set up their converter to plus 26, their records would be 6 dB louder than if they were coming in with plus 20. And you'd have tried to tell someone like that who just sniggers. You can hear over the phone how stupid they think you are, who don't agree with them. And they are just going to be so famous. And there's one from Los Angeles who was talking about the 2 dB extra. Well, he went out of business within less than a year, but it obviously didn't work. Actually, it was 4 dB, it was. But it obviously didn't work. I've recently got someone in South America that wanted to have this thing, a limiter set up to plus 24, because he got it because everything clipped too badly in the converter, which his input is set to plus 20 max, so it's fixed to 20. And when he put the limiter in, it limits too much. Well, yes, because you got more level than you should into it. So if I set it up to 24, of course, it will still distort on the input of the converter. But here is another thing. So if you come into the converter with near to 0 dBFS, and you then put, again, sort of unwittingly, you might then add, if you have a plug-in, and you just do a little bit of boost of something, like a bass frequency, or you have a compressor with a slow attack on it, you've gone over that level. So now it has to be brought down. This was the curse with digital machines. The first generation of digital machines, multitracks, the very first one left the factory possibly set up to plus 28 on the output, which was more than anything could handle, the mixing console. The next generation was plus 24. You put that into an input of an SSL, and it didn't really have much more headroom than that. You add a little bit on an EQ and it would clip. Or puts the fader up just a dB, it would clip. And hence it got a bad reputation for not sounding good because of a Sony into an SSL. Didn't sound good. All you have to do is turn down all the line levels or recalibrate the machine to be set at plus 20 or plus 18 or a bit lower, even lower than that. If it was an analog machine, it would be plus 14, plus 15.
Yeah, well, see, the same thing applies to the A to D.
Yeah.
Because when I've dealt with things like with a head box, and I try to explain to people, you need to allow some headroom for your analog stuff on the input side to work.
Yeah.
You don't, if you set the box up so plus 20 is clipping on the converter, you don't want to set your peak limiter to plus 20. You might really want to allow for some headroom. Or if your peak limiter only has 15 volt supplies and it's only ever going to get a plus 20 out of it, don't push it to that limit. Allow it to be down plus 16, and at least it's got a little bit of room for it to work internally.
Yeah, because otherwise it will already clip on the input before the limiter kicks in. And this is, if you set up a limiter to plus 26 and the whole audio chain struggles to get to 26, what is it that you're going to limit?
Yeah, or you
There
clip,
isn't anything.
or even if the audio path was clean, you still clip the side chain so the thing doesn't behave properly.
No, so you need to, there is one of the things, you need to have headroom internally in things for it actually to work as well. But it is, leave something sort of, if you have a record, if you do a mix and you know that this, or mastering, this is not going to go through anything. This is done. Nothing is going to be digitally processed. Yeah, you can go pretty close. You can go absolutely up to 0 dBFS with your peaks, which is because no one's ever going to mess with it after that. That's done. finished. But that's not how it works, is it?
It never works like that, and
No.
even if you did nothing but MP3 or AAC encoded, you get peaks above zero due to the AAC encoding.
Yeah,
So
yeah.
even that is not a great policy, because even the fact that you put it on iTunes now, you have an unpredictable result from
Yeah.
that encoding.
Yeah.
So yeah.
And then you
have
had
to
the
be
other
careful.
thing about sort of clipping all these sort of disc mounts and things in the past, or low headroom in sort of the output amp sort of pieces you play back on,
Absolutely.
meaning
yeah.
that you get phantom levels on the output, and then you get it clipping there
Mhm.
as well. So it's not necessarily clipping in the mastering room or in the mixing. It might be clipping in the playback equipment.
But it would be great if people found another way, because level, we all know that something that is louder, we like it, but there are also creative level, like in the old days, and people are looking for that, but it's like they look at the wrong way of creating level, it's crazy.
Yeah, but you have
Mhm.
commercial songs, you have big hits.
Yeah, but
we've
there's
all
other
heard them.
ways, it's like
And they
people forgot
seem
it.
to sort of like travel a whole beach from one speaker, and they seem to be great. But then when you got fed up with the song, go back, it wasn't that hot, it wasn't that loud, it was just a song that wanted
It
to be heard.
sounded right, it sounded
Yeah,
effective.
it was a
not-
great song,
Yeah,
people
it was
liked.
not a,
And if they do, people
not a
actually
figure.
make an effort to listen to it. They don't want to. They don't sort of like.
no.
You don't have to throw it at them. They will.
No.
They will vie for it.
But it's like people today, they think if it's loud in figures, then it's good.
Yeah, well,
But it
loud,
sounds like shit.
loud always wins, but carefully listen to that loud, and you'll go, this thing is really distorted.
But
Yeah.
I mean, good production today is to make something that, melts together and works, and maybe sounds loud, but in a pleasant way.
Yeah, well,
Not
that's
in that
always good
horrible way.
production, isn't it? Or projecting itself at the listener, so that when you want to hear it, you can hear it. But going out, when I go and see friends in world class, really world class mastering rooms with world class speakers, everything is just world class, and I have to ask them. I always ask them. So, did you blow their speakers yesterday or this morning? Because it sounds like they're blowing the speakers. It sounds like the mid-range or the tweeter is blown. No, it's just what they're working on. It's so squared, it's so clipped, and particularly vocals are horrible, absolutely diabolically bad. I mean, again, and where things should be, there is a hole, isn't it? There probably should have been some kind of, if not a snare drum, but something there. But it's like they're singing, and the S's, for instance, it's like they've got a mouthful of saliva when they do it. It's so horrible.
I do a lot of de-essing. There are a lot of.
Yeah, but there's another story about de-essing. I mean, I've mixed a lot, recorded a lot of things, and I can hear that when you need a lot of de-essing in mastering room, it was because the singer's voice was very dull on that day. So you have to goose up treble a lot when you mixed it. And there wasn't any treble on the voice, but it was on the S's and on the consonants or whatever, especially European ones with hard consonants. And that's where they end up. And so, unfortunately, you end up with a record which is too bright on the vocal, but the vocal is still dull. That's often the case. And this is where they should use, obviously, clever money is on using a de-esser when you mix it, before it's embedded in the music.
Or you can use it to train your second engineer. Just, edit all the S's by hand. that's a good,
that works as a
exercise.
last
It
resort.
works very well until you forget to do it.
Yeah.
It's usually the
And it's time consuming.
yeah. So often, did you do that S's? What S's? But no, I think I've been there a lot of times with that, and that is the worst thing. Is dull. The voices are so dull on the day.
So we have one last question. Go ahead.
A couple of minutes ago, several of you mentioned the word plugins, and I understood that you still think that plugins today are not up to what analog equipment can do. Am I right?
Pretty much.
Pretty much.
Sure.
But this technology also involves, software programming for audio processing. So don't you think that there will come a day where it will be a threat for you guys turning up
Well,
analog equipment?
no. Here's what's going to happen. Some of it will get better. Some of it will become even more usable, but very, very close. But right after NAMM, I attended the Avid Developer Conference thing, and met a very interesting guy who came out of TRW. He was a software guy, and I forget, I got his card, I forget, I think he made some soft synth or something like that. But what his whole job was in all his years at TRW, and it was defense and aerospace, that kind of stuff, was analyzing why the software never met what one was trying to accomplish, and dealing with the errors that are always there from the software. And basically, you know, we talked about EQ, we talked about compressor, and you know, he's was completely in agreement that, you know, we'll be able to get very close, but because of the finite nature of the whole digital thing, it's never going to be exact. The other side of that is maybe you can think, oh, okay, we can go more precision, more math, blah, 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 find out some ways to get there. And all of a sudden, we need, you know, 20 gigaflops to do an EQ. You know, so let's get about 4 HDX cards and we got 1 EQ working. Well, I don't think that's going to work for anybody.
I think my opinion is it will eventually meet or exceed analog. It's brand new. Analog is 7 years old. DSP is only in audio less than a decade old. It's in the sharp part of the learning curve. The emulations are extremely primitive today. I mean, the emulations that are considered to be state of the art are not remotely close to what the actual analog box is doing. And when you look at what other industries other than audio are doing, as far as simulations and emulation, it is extremely faithful when someone is building a rocket or a power plant or whatever. It is all simulated to a high degree of accuracy.
Yeah, well, yeah.
Audio is some back alley, low rent operation compared to what's going on in some areas.
Yeah, and I
It's
agree.
not the finite nature of
I
digital that
agree
stops it.
with what you're saying, but there's two things here. One, why did guys who design digital servo circuits with motors, and if they want to say have the motor to respond to 20 kilohertz, why did they make their sample rate 10 times what the bandwidth was? So we got to have a 200 kilohertz sample rate to make a motor work to 20K. But for audio, we figured, you know, 44.1 was a good enough sample rate. So we have, there's something that's missing for audio, and probably it was a cost decision as much as anything to fit whatever,
Storage.
storage
Technology at the
that
time.
fits on a CD. The other thing, as a plug-in designer, the thing that we always hear is how many instances per chip? How much power is this going to hog for my computer? So if you had, you know, your 20 gigaflops to work with per plug-in or whatever amount of power you wanted, and didn't care because whatever the computer system was, it was going to be able to handle it, you know, that changes the world of it.
Yeah, but it'll happen. I mean,
Well,
we can
at what
buy a
cost?
terabyte drive right now for $50, and 20 years ago a meg was big. you know?
Yeah, but
Things improve.
Yeah, things improve, but at the same time, you know, if you need a terabyte of memory and 20 gigaflops to, you know, that's 20 billion floating point multiplies per second. If you need that to do a 100% accurate emulation, you know, it could eventually get there, but I don't think
it.
it.
Take the analog?
When it ain't going to be in our
But
lifetime.
that's
But
one,
I think
that's
that
one
they-
emulation.
yeah.
Then
Yeah.
you need more of them. You need like
Yeah.
48 channels, and then
Yes.
you need to mix it all together and calculate that.
Yeah.
And that's a big calculation.
I
So-
think that the turning point is going to be when you have guys like us sitting here, and you have sort of digital Dave sitting here talking about how he developed this circuit because it's something he missed when he was recording and mixing and doing this thing. He wasn't copying what we've done, but they've actually come out. It's good because it's good on its own merit. It's not as good or as close. It's not copying anything that we're doing or previous generation, but they've actually developing it from scratch, and it becomes an alternative to what we're doing, not just a sort of, at best, an accurate copy of it.
Yeah, yeah. The
But
alternative
so they
works.
develop it from scratch, and this is when they can use that technology to perfect it and actually beat what we are doing.
Sorry, I really have to wrap up. I'm sorry, it was very interesting. Well, I would like to thank everybody for joining the panel. It was great.